All right, so today we will learn about using TinkerCAD to build circuits and simulate them. So we'll do a couple of things. We'll first learn how to create an account, and then next thing we'll do is we'll learn how to build a simple voltage divider circuit like this. Use a multimeter function to test the value of the voltage across resistors, how to use the multimeter as a ohm meter, and other instruments that are available in TinkerCAD. So let's get started here. So first thing we want to do is launch a web browser and go to www.tinkercad.com, and then we'll create an account. I have already created an account by linking my Google account to the TinkerCAD, so you can do that as well. So let's do that first. So let's open up a web browser and create an account. Okay, so I'm at tinkercad.com. I open it using Chrome. I'm going to do a full screen real quick here. Okay, so I'm on full screen now. Here, what we want to do is click on Join Now if we haven't created an account, or sign in, of course, if you already have an account. So let's do Join Now for now. Uh, Under when you do join, you get an option if you're in school to do educator or students. We're not going through that option. We're going to create a personal account, so do that. Again, if you already have an account, you can sign in, but do create a personal account. When you say create a personal account, you can either sign up using an email, so you can do your school email or your personal email and sign up that way, or you can just link your Google account. Um, there are other options to linking your Microsoft account or Facebook account and so forth. So I went ahead and created, when I first created an account, I signed in with my Google. So I'm just going to go do that, and I'm going to say sign in. All right, so I'm signed in. So when you get to the sign in, you get to this screen right here, which has 3D design, circuits, code blocks, and lessons. So let's go with circuits. Click on circuits, and here are all the circuits I've already built in the past. But I'm going to start by creating a new circuit. So say create a new circuit. Okay, when you create a new circuit, so here is your full window. It gives it a funky name. We can change that later on. Um, Here is the window where we'll build our circuit. Here are all the components. So if you say all the components, you'll see resistors, capacitors, diode, uh, switches, potentiometer. This is the variable resistor. Uh, and then if you go down, there are the sensors, which we haven't used yet in this class, an LED that we have used, motors later on, and then battery packs, a breadboard. So here's the breadboard, and then similarly instruments, a multimeter to measure the voltage, current, and the resistor, a power supply, a function generator, and an oscilloscope. Of course, these are slightly different from the benchtop instruments that we've used in lab, but some of the functionalities are similar. So we'll play around with these in a second as well. Similarly, down here we have different integrated circuits. We've used the op amps right here, so that we've used this op amp in the past before. And as you get more sophisticated, there are other ICs and Arduino programming options and so forth. But for now, the first thing I want to do is basically find breadboards. One of the ways of doing that is to use a search feature, or you can scroll down the list. I'm just going to search for a bread, and it brings me an option of multiple breadboards. I like the breadboard small because it looks very similar to what we have in lab. So I brought my breadboard. I'm going to place it right here. I can rotate this breadboard by clicking on the rotate. Oops, sorry. By hitting the R button. Sorry, so R key on your keyboard. If you hit R, it rotates by a certain amount. So let me rotate it so we're facing up like this. Okay. Uh, so our goal is to build a very simple voltage divider. So I'm going to bring in a resistor. So I'm going to search for a resistor. Here is my resistor right here. So I'm going to bring that in. Okay. I'm going to rotate this resistor and place it right here like this, right? So on a breadboard here, if you look at this, right, it shows that the rows are internally connected. That's what that green connection, as I put my mouse over let's say row 1, column B, you see that row 1, column A, B, C, D, and E are all connected on the underneath with a metal bar, and that's what the green lines are showing. Okay, so I place my resistor across this notch right here, or the trench right here, so that the two legs of the resistors are not touching each other. So if I now double click on this resistor, I can see that the resistor is 1 kilo ohm, and I can change the unit right here. I can give it a name if I choose. Let me go change the value of this resistor to 5 kilo ohm. Okay, so I have a 5 kilo ohm resistor, and notice how the color changed, right? So again, how do I do that? I double click on that component and I see the value that I can change. I'm going to bring in another resistor. Okay, and this time I'm going to place it like this. So now I've created a resistor that goes from terminal 1 to terminal 2, and the terminal 2 of that resistor is connected to this resistor, which if I click on it, right now it says 1 kilo ohm, but I'm going to go change that to 10 kilo ohm. So I've now changed that to a 10 kilo ohm resistor. Okay. Uh, Now I have a resistor and another resistor. They look like they are in series with each other. Okay. But before I start anything, let me bring in a multimeter. So I have my multimeter right here. So let me bring that multimeter. The multimeter is capable of measuring the voltage, current, and the resistance. Let's find out what the resistance of this is. So I can grab a wire. So the way to wire things is to go to a port, single click with a mouse, and bring the wire to wherever you need. Double click and you are done. Okay, I'm going to bring from the positive side of the meter, and if I pause somewhere, single click, I can bend the wire as necessary. So I'm single click, I bend my wire as necessary. Great. Double click to end the wire. Right? Now you can choose the coloring of the wire. So I have this highlighted wire right now. Okay, so let me click on that wire, this highlighted wire right now, and I can change the wire color. So let me color that red. Let me color this guy black. Okay. All right. So now if I measure if I let's do circuit simulation. So if I hit start simulation, so start simulation, by default it starts at voltage. Well, it's saying 0 volt, which is correct because there's no voltage. We haven't given it any power supply at all. If I click on the resistance, I get 10 kilo ohm. And that, in fact, that's exactly what it was. I had a 10 kilo ohm resistor, and I just measured the resistance of this resistor as 10 kilo ohm. So here's me measuring this as a multimeter, right? Measuring the resistance using the multimeter set in a resistor setting. So let me stop that simulation and continue with the building of the voltage divider. Okay, so now let's put in a power supply. So I'm going to go bring a power supply. Power. We'll bring this power supply right here, just like in lab. So let's do this. Let's bring a wire from here to here, and I'm going to color that red so that I know I'm bringing it hot. This one is going to be negative power supply. I'm going to bring it here. I'm going to color that black. Okay. Now from here, from the power supply, so this red line, this power bar is now all connected just like a real breadboard. So let's bring that power to that top resistor. I'll color that red. So power comes from the supply, goes through this resistor, and what we want now is from this resistor back to ground. Okay, so I'm going to bring from this resistor back to ground right here, and I'm going to color this black. So created a full circuit right here. I'm going to bring this meter up top. This black I'm going to connect to ground, and this with red I'm going to put it right here so that I can measure the voltage across this voltage at this node. And since I'm measuring the voltage at this node with respect to ground, I'm getting the voltage across this particular resistor. Okay, so I'm going to set that as red as well. Okay, so now if I hit simulate, so I have a 5-volt power supply. I have a 5-volt power supply going from here to this resistor, coming out of that resistor through ground. Now here my voltmeter my multimeter is reading an error because I have it set as resistance. We should never measure resistance when the circuit is hot or is powered. Okay, so let me switch back to voltage. Now it's telling me that the voltage is 3.33 volts, which if you do voltage divider, here's 5 kilo ohm, here's 10 kilo ohm. So 10 kilo ohm is so the voltage across the 10 kilo ohm resistor is given by 10. Let me bring up a calculator. So it's given by 10 divided by the sum of 10 plus the 5 kilo ohm. So that's that. And what are we dividing? We are dividing a total of 5 volts. So we have 3.33 volts. So that's what we're seeing. So here's a very simple way of using a breadboard, a function generator, and a voltmeter. Okay, so this is a simple way of building a DC circuit. Now, what about if we needed AC circuit or we wanted to build a function generator and an oscilloscope? So let me start that simulation right now, and I'm going to add this. I'm going to keep this voltage divider circuit, but instead of giving it a DC voltage, let's give it an AC voltage from a function generator. So let's go search for a function generator right here. So I have a function generator. I'm going to get rid of this power supply for now. So the function generator again has the hot end, so positive end. I'm going to bring it here and I'm going to color it red. It has the negative end, which I'm going to connect to the where we had our ground connection before. So now I have connected in my power supply, which is a function generator in this case. So now if I click on this function generator, I can set the different parameters. So right now it's set to a frequency of 1 kilohertz. So we can change that to 500 hertz or whatever else you might want. Okay. Right now it says a 5-volt power supply with a DC offset of 2.5 volts. Okay. Well, what does this look like? So in order to see that in lab, we had used an oscilloscope. So let's bring in an oscilloscope. If I say oscilloscope, I see an oscilloscope right here. So what I'm going to do is I'm going to set this oscilloscope to just show me what the input looks like. So I'm going to bring and connect my oscilloscopes across the terminals where the function generator is actually supplying, right? So the function generator positive is to this red bar. So let's connect that red bar to the red part of the oscilloscope. And the function generator negative portal is connected to my black power bar, and that I'm going to measure using black wire on the oscilloscope as well. Now if I hit simulate, okay, now this is what I see. Uh, Here's my oscilloscope. It's hard to see right now. So click here, and I am able to change the time per division, right? So I can change the time per division, and here is a 500 hertz web 500 hertz. So if I set the time division to 1 millisecond, so instead of 1 second, time per division, if I set it to 1 millisecond, I should be able to see the waveform. So here I have a square wave setup, and here I see a square wave. It's telling me that from the top to the bottom, that's 20 volts. So if you see this, right, if you see this carefully, you see a uh, 20 volt on the oscilloscope swap. Unfortunately, in TinkerCAD, we used to be able to control the voltage division, but looks like they've taken that option away, and I don't see that anymore. So we're fixed. We are stuck with what we have in terms of there. I can go change this function generator to a sine wave, and I see that change to a sine wave right here. Okay, so I have so this whole division is 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a total of 10 squares in 20 is equal to 20 volts. That means each of these squares represent 2 volts. So let me see. 2 volts, 4 volts, and about half a square right here. So that's a total of 5 volts, and that's what we had right here. If I move this DC offset down, I see this. If I set the DC offset to 0, let me set this DC offset to 0. Okay, so here is my ground line right here. So that's my ground line. And again, notice that this change right here, the voltage square changed, so it automatically changes. Okay, so my oscilloscope, that's my input. I can put another oscilloscope to the output to see the effect of the voltage divider on here. So I'm measuring the voltage across. Let me color that red. Let me color this black. Right? Now, if I turn this simulation, I should see here the output across this. Uh, and let me get rid of this. Simulate. I'm going to say again 1 millisecond, and there we have the voltage. Now notice that this one looks smaller than this. Just be careful because this is telling me that from this top to the bottom is 4 volts, right? The time axis is this from here to here is 10 millisecond, and the y-axis, the overall y-axis is 10 volts. Here the overall y-axis is 4 volts, hence the output actually looks larger. So just be careful. That is one quirk of this thing you need to be careful about. Okay, so here's a simple voltage divider using TinkerCAD.